Welcome to Day 3, Equations Involving Fractional Exponents. You will need the 3 Ps, paper, pencil, and patience, as well as a graphing calculator. Today you will learn how to solve equations involving fractional exponents when the variable is part of the base. The keystone to this process is knowing how to isolate the variable. In other words, how can we get the power of the variable equal to 1? If we consider the power law, we know that a base to a power raised to another power is the base raised to the product of the exponents. So for the product to equal 1, a and b must be reciprocals of each other. In other words, the b we choose must be the reciprocal of a for us to get a result of x to the first power. This becomes a little bit more clear in our examples where we are asked to choose a b that does exactly that. In example 1, in order to make the statement true, we must choose a b that is the reciprocal of the power of x, in this case 2. So b must be the reciprocal of 2. Therefore, we choose b equal to 1/2 and check our result. If I raise x to the second to the 1/2 power, I see that the power law allows me to come up with a result of x to the 2/2 power when I've simplified, or simply x to the 1, which is what I am looking for. Similarly, in example 2, I want to have b as the reciprocal of 3/4 to make this statement true. So I will choose b equal to 4/3, perform my check, and see that it works out. Now that we know how to algebraically isolate variables with a fractional exponent, we can look at the steps to solve an equation that uses them. The first step is to isolate the base. This will inevitably be the variable you are looking for, and is the same process as a normal algebraic equation. In other words, get everything that is not the variable to the other side of the equation. Second, once you have the variable alone with the fractional power, multiply both sides by the reciprocal of the exponent. In other words, raise both sides of the equation to the reciprocal power that will get your variable alone and to the first power. Third, once you have written out your steps, use a calculator to make your work easier and write your exponent notation in order to show your work to get credit. Then use the calculator to calculate the value of x. Finally, as always, check your work to make sure you have the correct answer. In other words, you're going to plug the value of x back into the original equation and see if it comes out. Now let's practice the techniques with a couple examples. Remember that the end goal in all of our examples is to get x to the first power equal to a value. I begin example 1 by following my steps and isolating my variable. This is a simple equation, so it is a simple matter of subtracting 1 from both sides, and I'm left with x to a power on the left and 8 on the right. Second, I want to get x to be alone and to the first power. To do this, I must take the reciprocal power that x is raised to. In this case, since x is raised to the 3/2, I want to raise the left side to the 2/3 power. However, like all algebra, what I do to one side I do to the other, so I take the 2/3 power of the right side as well. On the left, after simplifying, I'm left with x to the first power. On the right, I am left with 8 to the 2/3 power. Next, I'm going to write my calculator notation and input the right side into my calculator. This will allow me to get a definitive value for x. So note, I have 8 to the 2/3 power is 8 caret parentheses 2 divided by 3 close parentheses. I'm going to enter this into my calculator, and I should come out to a value equal to 4. So I have a value x equal to 4. Finally, I'm going to check my work by plugging 4 back into the original expression. Using a calculator, I find that my answer is correct, and I am done. Example 2 is very similar and follows the same process. I start by isolating my variable through basic algebraic manipulation. Next, I want to get my variable alone and to the first power. To do this, I raise the left side to the reciprocal power of x. Note that my reciprocal is negative because my original power was also negative. And what I do to the left side, I must also do to the right side. So I raise the right side to the same power. At this point, you should have two options left. If you choose to use a calculator, make sure that you write your input notation in order to get full credit. Note that I'm using the input notation x equal to 3 caret parentheses negative 3. When you input this into a calculator, however, you come out to a value of 0.037 with a bar over it. In other words, 0.037 repeating over and over and over. To write a more exact value, both on your paper and for input in your calculator, use the Math Frac option on your calculator to get a value of 1 over 27. If you see day 1 video if you have any questions on how to do this. Another way to get this answer would be to note that 3 to the negative third power is the same as 1 over 3 to the third power. If you have a keen eye and this is easier for you, this is also an acceptable way to proceed. Either way, you should come out to a value of 1 over 27. Once you have your answer, you can proceed to do your check. Note as I go along with my check that I'm using 1 over 27 as my value as opposed to 0.037. I do this for a couple of different options. First, in the calculator, to use 0.037, you need to come out with the value when you calculate it with 3 caret parentheses negative 3. That leads you to all sorts of different input problems. You need to use the answer and make sure the answer is in the right spot. By using the Math Frac option or figuring out that you have 1 over 27, at this point, you can simply input 1 over 27 into the calculator as I'm showing you here, definitively knowing where it's supposed to go, and coming out with an accurate solution, which turns out to be the correct check. In examples 3 and 4, we have a starting value that is in radical notation. To solve these equations, we can convert the expression to have fractional exponents and then solve as we have from there. In example 3, we start by converting to a fractional exponent. To do this, we take what's underneath the radical, raised to the first power, and then divide the power by the index of the radical. We then distribute if necessary. In this case, it is not. And we are left with x to the 1/2 power equal to 16. Now we can proceed as we have in the previous examples. I once again want to get x alone to the first power, so I take the reciprocal power on the left, and what I do to the left side, I do to the right side. This gives me x equal to 16 to the second power. Using a calculator, I should be able to get a value of x equal to 256. The check is equally easy, as my index was 2, so I can simply use the square root function of my calculator to see that I am correct. Example 4 is more involved, but uses the same process. First, I recognize that 3 is simply a coefficient, so I'm going to bring it down. Now, some of you may want to divide it out at this point. That is an option, but I'm leaving it in for a very specific reason that I'll show you at the end. Next, I want to convert my radical by taking everything under the radical to the first power, dividing the power by the index, and distributing to the terms within the parentheses. So here, I'm left with on the left side 3x to the 2/3 power, and on the right I'm left with 12. Now I proceed as I have with previous examples. I isolate the variable by algebraic manipulation, here dividing both sides by 3. And getting x to the 2/3 equal to 4. Next, I want to get my x alone and to the first power. So, I take the reciprocal power on the left side, and what I do to the left side, I must do to the right side. My powers on the left cancel out, and I'm left with x, and on the right, I'm left with 4 to the 3/2 power. Next, I input my values into the calculator to get a value of x equal to 8. Finally, I check my answer by plugging 8 back into the original expression. However, since the original expression cannot necessarily be entered into your calculator discretely, you should use the fractional exponent notation, as I have, to check your answer. This is the reason that I didn't divide the 3 out originally, because I wanted to show you how you can use the original equation in a different notation and still come out to the same answer. Here are the things you should be able to do. If you're having trouble with any of these, go back and rewatch the video focusing on what you're struggling with. Until next time, this is Mr. Mackman, signing off.